trying to do my work and you're blocking everything. I mean, look at you. I mean, you kind of opened the door there.
Hey.
I need to what?
Get off the bed.
Get off the vape? You're right. On the way to school this morning, I was hitting it hard. Blinkers? Is that what they're called?
It's always what you do.
When she's attacked, she lashes out. Yeah. Seems like projecting a little bit. Yeah.
Ellen, don't say that.
We meet up at the gas station at like 7. Then we blink. You call them blinkers? I don't know. We hit the blink. We hit that blink. We hit them blinkers. Is that better?
I can't do it.
Alright, quiet please. You should have been with us at 7. Feel better. Alright. Are there questions on how to find the regression equation? That's good? Okay. So then give the slope and interpret it. The slope is the number in front of the x. Slope equals negative 0.64. And then to interpret it, what's the y value? What's the y variable? Hours per week or average score? Average score. So average score is it's like y over x, right? It's average score over practice hours. So this is really like negative 0.64 over 1 if you want to think about it. So we would say as practice hours increase by 1, do I say the average score goes down by 0.64? Or we expect the average score? We expect the average score to go down by 0.64. Why is it going down, not up? Because it's negative. Y-intercept would be 94.86. So you could say y-intercept equals 94.86. Or you could say y-intercept equals 0, comma 94.86. Because that kind of reminds you there's an x and a y. So that means if someone practiced 0 hours, we'd expect an average of 94.86. So yesterday we had like negative shoe size or negative height or something, which doesn't make any sense. Is this like reasonable in real life? Yeah. I don't know if like the slope and the score is right, but it's a reasonable thing that if you practice, you're going to have a worse score. Or don't practice. What average score would you expect for someone that practices 30 hours a week? So you're going to just plug in 30 for x, which I can do in here. So negative 64 times 30 plus 94.86. Whoa, that didn't work. Hold on. Negative 0.64. Did you guys get that? 75.66? So all I'm doing is plugging x, the 30 in for x right here. Just putting it in that equation. And then can we use this to predict someone that practices 80 hours a week? We cannot, because that is outside of, like, our data goes from 0 hours to 40 hours. We can't assume the pattern continues beyond that. What would that be called? Extrapolation. So there's this thing on the there's a thing on the AP test, like if you don't remember the vocabulary word, just describe it. Like if you're like, I know there's this word, I know you could say the answer to this question could be no because that would be extrapolated. And you could be done. If you didn't remember that word, just describe it. Say like no because that would be going outside of our data set or something like that. And that applies for all the things. You don't ever have to remember like the actual word, you can describe it instead. Questions on this? No, this is basically what we went through yesterday. Alright, take out your note packet, please. It's tough to know when you're cleaning as much as I am. The breeze? Oh my god. I'm learning so many words. No. Let's talk about statistics. Okay. We're gonna breeze through a lot of this, but a couple vocabulary words to hit. The type of the data that it does. Okay. We worked with bar graphs, box plots, dot plots, and histograms. What did those all have in common? Not the case anymore. What? Well, this is still a graph. What's all the what? So these. What's the difference? Why is that different than anything we did last year? Yes. Last unit, everything we did on one variable. That's called univariates. Again, the word isn't important. If you have to write that out of the AP test, you can't remember the word univariate. Just say like one variable. And then now we are doing bivariate. Again, if you can't remember the word, it's not that important. Just put two variables. I've never seen those words on AP test. These I have. So we have called a response variable. That's just the outcome of a study or an observation. And you might want to spell it like that. Response with the Y, because it's the Y value. The response variable is the Y value. And then an explanatory variable. That's like your input. So independent, dependent, X, Y response. So down here we'll kind of join those together. So the X variable is the independent variable. It's the explanatory variable. It's the input. And then it's on the x-axis, right? Because it's the X variable. And then the Y variable is dependent. Because it depends on X. Like your average score depends on how much you practice. It's also called the response. And it's the output. And you will see these more than independent and dependent because independent and dependent mean like something different when we get more into probability. So to avoid like any confusion, they usually use these two. Alright, turn the page. So when I asked you to describe univariate data, one variable data, we had an acronym we used, which was SOX. Shape, outlier, center spread. When you're doing a scatter plot, it's form, direction, and strength. I don't have like a cool way to remember that. Or direction, form, strength, whatever. But those are the three things you're going to identify, so we're going to kind of look at those three things. So form, it can be linear, exponential, or logarithmic. Almost everything we do is linear, and it doesn't have to be a perfect line. So something like that would be linear because in general that makes it looks like a line could go through that. Exponential, like a parabola kind of curves upward. So you get something like that where you can make like a curve through there. And we don't work with that very often. And then logarithmic would curve like the other way. So logarithmic would look direction is just positive or negative. It's just like uphill or downhill. So positive is uphill. It's downhill, and it doesn't have to be like super steep. Like the uphill could be like that, or it could be really steep. The downhill could be really steep like this, or it could be a little flatter, still sloping down. Like a turn the page. Alright. Strength. So we're going to talk more about strength in a second. But for right now, the closer the points are together, like toward, we're going to pretend everything's linear right now, basically. The closer the points are to making a line, the stronger it is. If you can kind of see a pattern through the dots, that's really weak, and then moderate would be somewhere in the middle. So a weak relationship might look something like that, where like I can tell it's kind of going up, but it's not anywhere close to perfect. Like those points are pretty spread out. Strong would be like you could almost draw a line through it. That's strong. And then moderate, is kind of in the middle. Like that. And there is a way to like find a calculation that tells you, so you don't have it's hard to look at a graph and be like, yep, that's moderate. And they understand that and they're flexible. Like if they gave you this graph and you said weak or moderate or strong, it would probably be fine. If they gave you this graph, they might even take moderate for that one, they wouldn't take weak. And if they gave you this, they'd probably take weak or moderate, they wouldn't take strong. So like there's wiggle room. Yeah, let's do that. I want you to do that one. So we're going to make a scatter plot, and then we're going to describe the relationship. Proper description. Should we cross out cigarettes and put blinkers? I've never heard that before. So read this first sentence to make sure you know which variable is which. The number of doctor visits a person has can be explained by the amount of cigarettes. So that means the explanatory is the SIGs. Or just think through it. Like, does smoking a cigarette lead to you going to the doctor? Smoking cigarettes. Or does going to the doctor lead to you smoking cigarettes? Right? Like cigarettes are going to lead to doctor visits most likely. So that's your X variable. So that's one way you can tell. The other way is if it's in a table, the X is always on top or on the left. It'd be like X, Y. So you're not even doing a line of best fit on this. We're just finding the. Oh, I gotta show you how to make a scatter plot. That's what this is for. Alright, put the data in your list. We have not made a scatter plot yet, have we? What do you need, Beck? Jackson! What would you say at that point? Jackson. No, I don't have fast forward through this. I don't want to take the time to like I don't want to make a scatter plot. I'm pretty sure you know how to make a scatter plot, so we're not going to do it for real. But my dots look something like that. Fair enough. To make it on the graph. Not really. If we do, I'll show you. I mean, I'm not going to put it on the test if I haven't shown it. I would rather use our time to do something else right now. So what I really want to get to is describe the relationship. Like, that's the point I'm trying to make. If we have a scatter plot, we'll do it later. So your job is to describe the form, the direction, and the strength. So I'm going to say there is a form. We got linear, exponential, logarithmic. It's almost never those. It's almost always just linear or non-linear. Does that look like a line? Looks like a line to me, or pretty darn close. So it is a linear. That's your form. Positive or negative? Uphill or downhill? Positive, so linear, positive. That's your direction. And then would you call that strong, moderate, or weak? That's pretty strong because those dots are really close to that line because the line would go like right through there. Strong. That's your strength. Relationship. Am I done? Probably not. What do I substitute? What? I gotta lay it. That's like a graph that's not labeled right there. Like if I have to describe it, and I just said, hey, there's a linear positive strong relationship, you'd be like, what are you talking about? I don't know what variables you're talking about. So you're gonna say between cigarettes, cigs, and doc visits. So that's like labeling your graph. It's like putting context. Context. Off to the side here, do you have room to make another little tiny graph? You don't even have to make it. Just watch mine. This is your tardies, my happiness. Describe. So take a second and describe that relationship. Whether you write it, do it in your head, whatever. But I just want to practice another one. What? What? Oh, I cannot control how you feel. Only you can control how you feel. Some of you, when you're absent, I get happy. Alright, there is a linear, negative, I would say moderate. I think weak is acceptable. I think strong is acceptable. Like, that's pretty great. Relationship between parties in my head. So make sure you have that like context in there also. Alright, is that part okay? Just describing it? Great. Turn the page again. Okay. Correlation is a number that's between -1 and +1. -1, let's just draw it. -1 could look, I'm going to draw two of them, one in X's and one in dots. It could look like that, where it's a perfect line sloping downwards. Or it could look like this, where it's a perfect line sloping downwards. The point I'm trying to make is the slope of it doesn't really matter. Like -1 versus -2 versus -3, I don't care. It's negative is really all that matters. And the points are perfect you know what's weird at our school? Never mind. Here, if you graph at our school like GPA down here and SAT score on the side, like you would expect your GPA to predict the SAT score, kind of, right? Like a higher GPA, you would expect a higher SAT. Our graph like looks like this. Like there's the grades don't necessarily reflect how you would do on the SAT. That's kind of what our data looks like. R equals 1 would be perfectly positive, so you could get like this. It could be slightly sloped upward like that, or it could be perfectly sloped upward like this. Make sure you realize that's more. It's not like one graph, that's like two examples. So then you get like things in the middle. So like R equals 0.2, what would that look like? Well, R equals 0 is no pattern at all. 0.2 is not that much bigger, so R equals 0.2. I'm not great at drawing these, no one is. Looks something like that. We're gonna do an activity in a minute that you'll get to like kind of guess these. And no one's ever gonna say, hey, plot R equals 0.2. That's not a thing that's gonna happen. Just trying to give you an idea of like what the numbers mean. And no one's ever gonna look at that graph and say like, tell me what R is. Just try to get an idea. R equals 0.9 would be pretty darn strong, but not like a perfect line. Just close to a perfect line. And then R equals 0.5 would be kind of in the middle of those. Maybe something like that. And then like in general, this would be weak, moderate, strong. There's no like when you get to here it's strong, when you get to here it's moderate. It's just kind of vague. It's not great, but that's how they work it. After the bench. So this is the same idea, it's just negatives. So negative 0.9 would be pretty darn close to a straight line going down, but not perfect. You can see my dots. Negative 0.65 is going down, but not as tightly packed as the 0.9, so maybe something there. And then R equals negative 0.3. Like I can tell it's going down, but we're still pretty spread out. So maybe like that. I was gonna get this as a fact number 4. Correlation has to do with how close things are to making a line. A line, not a parabola, not an exponential, not anything. How close is this graph right here to making a line? It's not. Like if I try to draw a line through there, I don't even know where to put it. So is this closest to R equals 1 or R equals 0, or where are we at? This would be R equals 0. There is not a linear pattern there in any way. So correlation only describes linear relationships. So like I can predict that, but it's not. It does not have a high correlation, a high R value. Correlation does not have units, and changing the units or switching the axis or whatever you do doesn't affect correlation. Like if I eat more calories, I'm going to gain more weight. I don't care if I measure it in calories or joules or kilocalories or pounds or it doesn't matter. That relationship still exists. You can measure however you want. Or like the more sleep, the less sleep I get, the more tired I'm going to be. I don't care how you measure it, minutes, hours, seconds. That relationship still exists. So switching units or anything will not change your R value. That's fact number 6. Okay. And then we're going to get into this in a couple days more, but correlation is very So imagine you had like that. What's R right there with those 5 dots? Basically 1. Well, now I'm going to put a point over there. That's going to change R a lot. So an outlier like that will make a big difference. It's really the end point. Alright, go to school. Did you guys play this last year, the R guessing?
Probably not.
In regular stuff? Yeah.
We don't have one.
Not in pre-calc, in stats.
Yeah, and then I had to go get it. The car was unlocked all the time. Someone's gonna take all my tools. Oh,
Let's do click on the second game first. I just want to do like a couple together. And then I want you guys to just practice. So look up here at mine. Let's do a couple together. This is a weird example, but because there's 2 that are the same. This one up here, top left, is positive, right? That's pretty strong. So what do we think that is? 183. This one's positive, but not as strong. And then these 2 are both like the exact same, so I don't know which one is supposed to click which, but I guess I got it right. Alright, this one's better. This one on top left. Which one do we think that, if we said A, B, C, and D, which one do we think that is? That one's going to be D, because it's very strong, and it's negative. What about this one, A, B, C, or D? That's going to be C, because that's pretty darn close to just random chaos, you know? It almost looks like just a circle. So this, I'm choosing the one that's closest to 0. This is positive, but not that strong. And then this one's positive, but very strong. And there's this other game as well. So I'm just going to give you guys, I want you to use this time to like practice, play those games a couple, and it just gets like, it gets the R in your head. Like you kind of start to understand what it means a little bit more. You'll see that it's like impossible to guess exactly. You want to have some general idea.